Hi everybody, this video is going to show you how to solve the ideal gas law. So up here, up at the top of the page, we've got the equation PV equals nRT. So we multiply pressure times volume, and N and R, they're new. So N is moles. You can use the ideal gas law for moles. That's the difference between this and, say, the combined gas law. And then the other one that's new is R. We've got a table down here that's called the universal gas constant. And we have a bunch of them because R is basically just a number that makes this equation work. So we're allowed to change our pressure and volume units. Temperature will still be in Kelvin, but any values that we use, we just pick the appropriate R value. So this looks like a big mess. R is designed to cancel out all the units except the one we're looking for. So all these things, that's not something that you have to plug in. That's just the units of R. So when we pick our R value, we pick it based on which pressure and which volume we're given in the problem, and that will just make the numbers work. So pressure, volume, temperature, we're familiar with. This one can do moles, so we can get the amount. And that's the moles is the key that tells you when you're using the ideal gas law as opposed to one of the other ones. So we're going to do two examples together, and I'm going to write out my variables here. Remember, you don't have to do that. We'll plug them into the equation and we'll solve for one of these four. So like the other gas law problems, you have to know all but one variable. You can only solve for one. So in our first example, we have liters. That's a volume unit, so that'll be our volume. We've got temperature. That's in Celsius. We'll have to change that to Kelvin. And then torr is our pressure. So we'll fill in what we know. So we've got 756 torr. So that's our pressure. Volume is the 0.78 liters. The temperature is 25. So let's do 25. We want to turn that to Kelvin, so plus 273. And that's 298. And then for N and R, we're going to be finding N, because the question asks how many moles of gas are in the bottles. We don't know that one. And for R, we pick it based on our units. So looking at what we have in the problem, we look at our pressure, which is torr, so that's one of these two, and our volume is in liters. So that means we're in this row. So the number we're going to use for R is the 62.364. And the units of that whole thing are liters times torr divided by moles times Kelvin. And that will make everything else cancel out except for moles. Okay, so our equation is P times V equals N times R times T. We plug in our numbers. So we've got 756 torr times 0.78 liters equals N. We don't know, so we're just going to leave that as N times 62.364 liter torr over mole Kelvin times 298 Kelvin. All right, so we got our variables plugged in. We're trying to find N. To get N by itself, we want to divide by everything else on that side. So we're going to divide by, you can do the math over here first. That's fine, however you do your algebra. I'm just going to keep them as numbers, and we'll do the same thing on this side. These cross out. And then just trust me that these are going to make the units cancel out. Run a little low on space. And we plug in this 756 times 0.78 divided by 62.364 times 298. And I got a very small value. If we're following sig fig rules, volume is our limiting one. That only has 2. So our answer is going to have 2. So I got 0.032. When you do the homeworks, it'll tell you how many sig figs you want. And that's moles for our units. So that's the final answer. So what's nice about this equation, the original equation PV equals nRT up here, is that it's flat. We don't have any fractions. So whatever you're trying to find, you're going to divide by everything else on that side when you're finding the number. Yeah, so that's the first one. Let's look at our second example. So we've got, what is the volume of moles? So let's plug in our moles number. So that's the 0.91. And it says STP, pressure in atmospheres. So remember, STP, we have the chart that tells us temperature and pressure. So it's always 273 Kelvin. And then it tells us to put the pressure in atmospheres. That's going to be 1 atmosphere. So pressure will be 1 atmosphere. Volume, we don't know. We'll come back to R in a second. And we've got 273 Kelvin. So R value, we're going to scroll back up. So with this one, we're not told what units to do for volume, so that you do have the choice between the two of them. But our pressure's in atmosphere, so that's going to tell us which R value we need. So we got a pressure in atmospheres, so you can either use this number, then your answer will be in liters, or you can use this number and your answer will be in milliliters. I'm going to put the answer in liters, but if it doesn't specify, these are equally correct. So this number, the 0.08206, is going to be our R. So I'm just going to write here that we're using ATM and liters. So we're going to use the 0.08206. I'm just going to leave the units out for now. We'll put it in the equation. All right, so we've got our equation, PV equals nRT. Plug in what we know. So we know the 1 ATM. We don't know V. Our N is 0.91 moles. The R is the 0.08206. Now I'm filling in the units, which will cancel out. And R 273 Kelvin. All right, we're trying to get V by itself, so we divide by 1. Plug all this in the calculator. And this one, again, this time N is the one limiting us for our sig figs. 2 is the best answer. So this comes out as 20.4, which rounds down to 20. 20 would only be 1 sig fig. So the best answer is 20 liters. All right, so we did one for volume, we did one for moles. You can also solve for pressure or temperature in Kelvin. Works the same way. So this one, again, remember that ideal gas law, you know to use it because it's the only one that has moles in the equation. All right,